In order to find the magnitude and direction, finding magnitude and direction of a vector finding the magnitude and direction of a vector given a point where the vector is ending. So what we will do is we will create a right triangle by drawing a vertical line from the end of the vector to the x-axis. So for example, let's find the magnitude and direction. Find the magnitude and direction of a vector ending at the point 4, 1. So we'll start off with a vector in quadrant 1, and then we'll do one in a different quadrant. So 4, 1, so the vector is ending at the point 4, 1. So if we drop down a vertical line, then if I label what I know, this is 4, this is 1, I should be able to find the magnitude. Magnitude is the length of the vector, and a lot of times we denote this with an r. So I should be able to find that first using Pythagorean theorem. So r squared, so let's switch back, I'm going to switch back to blue. R squared equals 4 squared plus 1 squared. So 16 plus 1 is 17. So r is the square root of 17 exactly, but this is approximately 4.12, which makes sense. It should be the longest side, and it looks like it's just a little bit longer than 4 because it's just vertically up a little bit. Okay, so then now to find the angle, so I'm looking for this angle right here, the direction, because straight to the right is 0 degrees, so the direction is going to be that angle to get up to the vector. I should be able to use tangent of my angle, theta, is opposite over adjacent. So my opposite side is 1, my adjacent side is 4. So when I do tangent inverse of 1 divided by 4, I get about 14 degrees, 14.0, so 14 degrees, which that looks reasonable. It looks like a pretty small angle. So that is my magnitude and direction. So this is a vector 4.12 in length at 14 degrees in reference to 0, where 0 is straight to the right. Okay, let's also do one in a different quadrant. So this one we're going to find, I'm just going to use r and theta to do shorthand for instead of writing out magnitude and direction. We're going to find the magnitude and direction of a vector ending at the point -2, 5. So here's -2, 5. Here's a vector ending there. You can imagine that's a straight line. Make that a little more straight. Okay, so here's my vector. So to find the magnitude and direction of this one, so I'm going to drop down my line to make this into a right triangle. So I have -2 on the bottom, +5 going up. So first, if I want to find my magnitude, my r, I can do, actually let's write this as r squared r squared equals -2 squared plus 5 squared. So I've got 4 plus 25 is 29. So r is the square root of 29, or approximately 5.39. So 5.39 is my magnitude. Now to find my direction, so I'm looking for really from 0 right here. That is the theta I am looking for. So if I set up tangent, now really here on my triangle, this is not theta, my direction. So I'm going to denote this with a capital A. So for that angle, I'm looking for that angle. Tangent of A would be opposite 5 over -2. So when I do tangent inverse of 5 divided by -2, I get, let's see, tangent inverse of 5 divided by -2, I'm getting -68.2 degrees. Okay, now that's obviously not my direction. My direction should be somewhere, it looks like a little more than 90. So let's think about this. So -68.2, where that is, if I go negative direction, it looks like about here. So this makes a straight line, -68.2 degrees, with the vector, but it's going the other direction. So our calculator only can output in 2 different quadrants, so we have to do some figuring out typically, unless we're in quadrant 1, like in the last example. But here, over in quadrant 2, we're going to have to do some figuring out. So if this -68.2 is between the x-axis and this vector down in quadrant 4, then that means that A is a positive 68.2. So this A right here, this is 68.2. So I'm trying to figure out between 180, there's 180 degrees, here to here is 68.2. So to figure out that direction, what I can do is I can take 180 minus 68.2, and I get 111.8 degrees, which that makes sense, a little bit past 90 degrees. Just the way it looks, that seems reasonable that would be 111.8 where my theta is.